So given an m cross n binary matrix, okay, matrix is given, return the distance of the nearest 0 for each cell. The distance between the two adjacent cells is 1. Okay, so that means for each cell the nearest distance, it is 0. For this it is 0, 0, 0, 0, 0, 0, 0, 0, 0. For this the nearest 0 is 1. For every cell, find the distance of every of the nearest 0 for each cell. So for this, okay, so for this 0, 0, 1, triple 1. So let's see 0, 0, triple 0, 0, 1, 0, triple 0, 0, 1, 0, 0, 1, 0, 1, 1, 1. So what should be the answer for this? For each cell, what's the, so for the cells which are 0, the answers will always be 0. No, yeah. Okay, so the non-zero cells, go till we find a 0, but that 0 should be nearest 1. Okay. So what if, okay, so for if that is 1, for this 1, what should be the answer? So this is okay, for this 1, it is surrounded by all ones only. So I can jump to this one and then either of the zeros, either 3 of the zeros. So answer should be 2 for this one. So this is for 0, answer is 0. For 1, for this one, answer should be 1, it is 0. For this one, answer should be 1. For this it is 2. For this it is 1. Is this 0, 0, 0? Okay, I understood the problem right. Let's think. Okay, so the distance of the nearest 0 for each cell. For each cell, the distance of the nearest 0. So if it is a non-zero cell, one problem is I can just run a DFS from every non-zero cell. DFS or BFS? BFS, shortest path, BFS from every non-zero cell, and that will give me the answer. But do I want to do that? Every non-zero cell, run a BFS. Yeah, that means go visit, but the problem will be which one to visit. So if I'm at a non-zero cell, I have 4 neighbors. So 2 of them are non-zero, but 2 of them are 0. So which one should I visit first? I think, yeah, there is an order in, yeah, so the order of the neighbors matter here. So in which order I should visit the neighbors? So the order should be, if it is 0, then directly visit that 0, right? So if all of them are okay, then answer will be 1. But if all of them are non-zero, what will happen? So all of them are non-zero, then which one should I visit first? I should visit that one which is nearest from any other 0, right? Is this correct? Is this claim correct? So from any, so if there is any okay, I will traverse only from if all the neighbors are non-zero, that means I should visit that node first which is nearest from which is nearest from 0, right, which is nearest from 0. So I am standing at this one, so I should visit, so let's extend this, so 1 1 1, what will be the answer? So I am standing at this one, I have 3 neighbors, so what if it is 1, what if it is 1? Then for this neighbor I should visit, I can visit any of the ones, so this and this, but I would want to visit this one first, then this one or this one, because this one has the distance of 0 already. Okay. So if there is no 0, what will be the answer? So if there is no 0, what will be the answer? This should be a condition. There is at least 1 0 in matrix. Okay. So from that 0, I have the beginning nodes. I can have from this 0, I can visit all the non-zero elements which are in the neighbor of this 0, which have the distance 1, right? They will always have distance 1. Okay. So from there I can visit the next node, next non-zero node, right? Because these will have answer 1. Okay, so from here, but so from 0, okay, I visit the node 1. See, from 0 I visit the node 1, which has distance 1. I visit the node 1, which has distance 1. So these nodes are visited in first. So this one is visited. Let's say this one is visited, and these all 3 nodes are visited. If we visit all the non-zero nodes which are the neighbor of a 0 node. Okay. So what will happen now? If that means if I know the distance of this node is 1 1 1 1, that means if I have 0 here, what will happen? Then what will happen? Okay, so for this one I have the answer is 1. For this node, for this one, if I visit this one, answer will be 1 plus 1, because the distance to reach here is 1, the distance to reach here will be 2, but I can also reach this node from this node, this one also, so that will be answer 1. I can reach from here also. So what if it is 0? Then for this node answer will be 2, right? For answer will be 2 from these 2 nodes, but answer will be 1 from this 0 node. Okay, so I think Dijkstra. So first visit all the non-zero nodes. And from there go on visiting the neighboring nodes which I can visit. Neighboring nodes which I can visit. is this correct, in a priority queue, because the order of the neighbors matter when I'm going to visit a node. Order of the neighbors matter. Okay, so put, I think it should work. The Dijkstra. So first find all the nodes which are 0. So from there I have all the nodes which are at 0. From there pick the first 0 and go to all the non-zero neighbors. Okay, mark the distance as 1 1 1 1 1, then put them as the nodes, okay, in a sorted order, in an order of the ordered by their distances. Okay, then pick that node and try to visit the non-zero nodes. So because that node I can reach in the minimum time, that's why I'll pick that node first from the so try to visit all the possible new nodes, new non-zero nodes, right? So from 0, because answer cannot be greater than 1 for 0 and 1. Okay, I think it should be solvable by now. Matrix, update matrix, where we have the matrix given m cross n. So vector of vector update matrix. So we have the matrix. So first let's put all the, find n is mat dot size, let's call it grid. Okay, so we have m cross n. Okay, so number of rows, number of columns. What if there is no, so this should be greater than or equal to 1. Okay, we are fine. So let's put all the nodes which are j is less than mj plus plus now. So if the grid of ij is 0, that means my node, let's put it inside the set. Let's put it inside the set. So set of what the ordered by their distances. So it is distance, and what is the location of that node. So that is a pair of, okay, so pair of intent, this distance versus location. Okay, so we can put st dot insert, what the distance will be 0 and location will be I comma j, right? Okay, so we'll have let's put all the nodes one by one. So while my set is not empty, let's pop the first element, which is st dot begin. St dot okay, this will point to the begin, and we have deleted begin, so we need to, okay, so this is the distance to p. to p is equal to st.begin, first element. That means my source node is nothing but, yeah, where I am standing, it is I, is nothing but p dot, it will be star of st.begin, the value of that node. So p dot second dot first, p dot second dot first set of when does the set is to set of pair of integer, pair of the location. Okay, so this is fine, this is fine. So set of pairs where the first is the distance and the second are the locations, which is fine here. Okay, 1 2 3 1 2 3 st. So p dot second dot first, and what's the jth location is nothing but p dot second dot second, p dot second dot second, and what's the distance, and d is nothing but p dot first. Okay, erase it and go to the neighboring locations of this. What are all the neighboring locations of this node? So k is 0, k is k plus plus, so we can go to that location. So for that we will need dx of 0 0 minus 1 1 into d by 4 is equal to 1 minus 1 0 0. Okay, so for all the neighbors I want to go to at dx of k, and y is nothing but j plus dy of k. So x is I plus dx of k, y is j plus dy of k. Okay, so set is not empty, and so if I visit a non-zero node, so from all the zeros, let's pick the node which is the least distance. Okay, least distance, and from here go to a node if and only if. So what's the condition? X greater than equal to 0 and x is less than n, and y is greater than equal to 0 and y is less than m, and the distance, that means the grid of xy should be non-zero, right? Then only visit. That means if inside that grid, and from this ij I can go to xy, and xy is a non-zero because 0 is already cal in my set. All the 0 are already in my set. It will be non-zero. Okay, if it is non-zero, then only do this. What should be the conditions? From I to j, if I can reach to a node, okay, the distance will be d plus d is the distance to reach at ij, so d plus, and I am going to a non-zero node from a non-zero, so 1 plus d, right? So 1 plus d will be the new distance. So 2 I need to update it. Okay, we need the distance vector also, distance of each node. So I think that will be a 2D matrix, vector of, so distance and of m, so distance of each node, distance of each node in the beginning will be 0 only, right? So distance of that 0 0 node will always be 0. That's why I say, okay, I need to go to, so 1 plus d is the new distance. If I, so new distance should be lesser than the current distance of xy. Then only, so let's mark it as infinity. What is the infinity? So const int infinity. What's the maximum distance? 10 raised to 4. So m plus n minus 1 can be the maximum distance. So you can easily write 10 raised to 4. So 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is infinity. So if the distance, every node's distance is infinity initially, and we mark the source node as 0, go to the neighboring nodes if and only if the new distance, which is 1 plus d, the d from where I am visiting, and distance of xy is the distance, current distance. So if that is the case, okay, we can put it inside the and only. So if that is the case, otherwise, why to visit that node if I'm increasing the, so there is a node which has the distance less than 1 plus d, and I want to give it 1 plus d. Why to visit that? No need to visit that. So I can, and 1 plus d is less than so if that is the case, so from I to j, so what is this? From I to j, ij xy, if xy is inside, as well as this is a non-zero node, as well as what's the grid of ij? This condition will always be false, right? Because distance of 0 0 will always be 0, which is always less than 1 plus d. That means we can remove this. Grid of 0 0 is not 0, because that will be filtered out here. Why? 1 plus d is less than 0. It will never visit a 0. Okay, so 1 plus d is less than d, distance of xy. Then we can mark the distance of xy. We can mark the distance of xy is 1 plus d, and we can mark the distance of xy as 1 plus d, right? And put it inside our set. But what if that d already exists? That means distance of xy and xy. So what if distance of xy already exists? If that node, xy node, already exists in the set, so that means we need to remove that first. So if that exists, so if st dot find the distance of, so current distance is xy and node is xy. So if that st dot find is not equal to st dot end, that means it exists. we need to erase that. st.erase this node, st.find of this distance of xy and okay, and distance of xy is equal to 1 plus d, and update the distance to 1 plus d and then insert that in the set. That means updated. For is fine, while so at this point we have all the distances, the distance of all the nodes, and the distance between the two adjacent cells is 1. I think we can directly return the distance matrix. Will this work? I think yeah, let's see. So const infinity, let's make it private. Okay, so public update, let's see initializations. So an m set of pair of int distance to the location st and distance. Okay. Then for every I, for every row, every column, if it is a 0, then we are inserting 0 I say and marking the distance as 0. Fine. So for every row column, if distance is this, we are marking the distance as 0 and while set is not empty, perform this. Set is not empty, find the first location and remove the first location, remove the source node from where the visiting will start. Go to that. Okay, so x, which node I am visiting. So go to the directions dxk, dyk, xy. Okay, so if it is inside, as well as the distance to reach that node, so current distance to reach that node is greater than the distance I am proposing while visiting that node from this node which is in my hand. So that means I can visit that node. Yeah, so that means I can visit that node. So let's visit, so let's go to that node. So new distance will be 1 plus d only, right? And put it inside the set, the new distance and the location of that node. But before updating, remove that from the set if that exists. So do I need to support the previous distance and this? If that was already there, then remove that and update it. Okay, I think this should be fine. Why so much confusion in the braces? Okay, after this we can, so this brace is for, we can return the distances matrix. No typo please. It is the grid, it is grid. Okay, it is, it passed the test base cases. Let's see. Okay, worked. Fine. I think it can be solved in other ways also. Okay, I need to think about it. What can be other way? what's the complexity here? So we will keep in the sorted order, just we are doing the find and erase and okay. So for every node, so n nodes, n cross n nodes into log of n cross n, so n square log n, 2 times n square log n, which is n square log n. Can we do it in n square without this Dijkstra? Dijkstra is working. Yeah, I'll think about it.